Welcome to the course of perception algorithms for autonomous systems. So, in this course we will be mainly teaching or learning the first what is an autonomous systems, what are the different kind of properties of an autonomous systems. We will talk about the autonomous system functions. Once this is complete, and we will take few real life example. One is on autonomous driver assistance systems, another one is an autonomous UAV based maritime surveillance and reconnaissance systems. So, we will know that how the autonomous systems actually behave in practice. Once this is done, then we will be autonomous system has three major subsections. One is obviously the estimation theory. We will be talking what are the sensors, they are the eyes of the autonomous system. We will be talking about the estimation theories and different kind of maximum likelihood, maximum a posteriori, least square, and we will be in detail talking on the Kalman filters as a whole. Also the nonlinear Kalman filters will be covered. Then we will be talking about different algorithms for multi-target tracking. Once this is completed, we will be switching to the sensor fusion part, the sensor data fusion and the sensor information fusion part. Once that is done, we will be talking about the classification part. So, tracking, sensor detection, sensor tracking, sensor fusion and the classification. So, D stands for detection, T stands for tracking, C stands for classification. This will be the entire gamut of a perception function of any autonomous systems. So, we will be studying at the end of the course that we will be knowing everything in a small nutshell. So, that we know how an autonomous system performs. So, with this introduction I would like to start today's first lecture. So, what is an autonomous systems? If someone is asked, suppose a human, we are a human. So, humans have our vision or sensory organs. We know our 5 sensory organs, your eyes, ears, your nose, your skin, everything and your tongue. So, you have 5 sensory organs. So, similarly, an autonomous system will also have a sensory or some sensors or the perceptions sensors. So, they are basically the eyes and ears of an autonomous systems. So, they take the information of the surrounding of the environment, and that information is kind of will be processed primarily within the central computer within the autonomous system. So, just like the informations from a human being, when we see or we gather the information, it is passed through our nervous system or through our brain. The same thing is being kind of processed in the central computer system of the autonomous systems. And what is the outcome? Outcome is actually your actuation action. So, similarly, when we see something, if we want to react, we raise our hand or we just move on using our leg. So, legs, hands, they are the kind of actuation system for the human if you consider as a human. From a robotic or any kind of autonomous system, it will be a set of actuator. So, any autonomous system, the functions of an autonomous system is divided into major 3 blocks or the 3, we call it as a 3 sensing stacks or 3 stacks or 3 functional stacks. One is obviously the sensing stack, then it will come your perception or sensing stack is alternatively known as the perception stack. Then something is called your navigation or localization stack, then come your planning stack, and once these 3 stacks are completed, then finally, so you will see here all the 3 stacks are completed, then you will finally come as your actuation stack or the control stack. Okay. So, now in the autonomous system has examples in both civil use also for the military use application. For the civilian use applications, we call it the functions, all the sensing functions, the sensing, localization, planning, control. This is called sense, plan, act, SPA. So, as you see here, this is your actually sense, plan, act cycle for any autonomous or robotic system, maybe an advanced driver assistance system. So, you want to take your surrounding environment of the road. So, you have your small FMCW radars, you have small cameras, and I will give some example in the subsequent part of my lecture. So, you want to take some pictures or some kind of snaps of the road, how the images, how your surroundings is there, or any kind of a mobile robot. Robot is traveling, suppose, or moving in a room. So, what is the vision? It could be some kind of camera or some kind of lidar. This. So, it try to map the whole environment. So, this is your sensing part. What is the planning part? Now, you got the data, you have the data with you, you want to process it. Where you will process? You will process into the some central system, central computer system. So, that is called the planning part. And finally, once you are planning, what you want to do is decide based on your perception information, you act, that is your actuation. You send command to your actuator, okay, right. In military terminology or in kind of military domain, the SPA, the Sense Plan Act, is being termed in a different way. In any kind of, you go work any kind of with the our armed forces or tri-service, any of them, they said it is called UDA. Both are basically same, both are same. There is no difference between SPA and Observe, Orient, Decision Act, UDA in the military terminology. So, sensing is again your observation. So, observe, you are asking, understanding. Orienting, okay, means now I am orienting to take actions. Okay, orient and decision are kind of a planning. So, this is your planning. So, observe is kind of sensing, planning means you want to orient, you want to decide, and act is actuation as usual. So, here the thing is that suppose you are kind of surveilling an environment with suppose some UAVs. Okay. With the UAVs, so UAVs has a vision. So, they have some your radar, onboard radar or some kind of onboard camera, which will take the information, See our national example, say you are doing with some kind of male UAV or say Tapas, you are with the Tapas, you want to kind of do some surveillance along suppose the Indian Ocean. So, Tapas is having some kind of its own radar, its own as its payload. So, with this it is kind of surveilling. So, this radar will work as your observer or it is a sensor which is mounted on a UAV. Now, the radar will take the data. Normally, what radar takes? Radar takes your range, azimuth, elevation, these informations. So, this orient and decision. So, this will be the part of your planning, and obviously, finally comes your actuation. Then, what the UAV is going to do? It will going to look for the target, or it will track a continuous suspicious target. That is a part of UAV or it will bomb the target, whatever it wants to do. So, that part is kind of your actuation. Okay. So, as per now 4 functional layers that I have talked is the sensing layer, localization layer I am coming, planning layer and actuation layer. So, now what thing is missing, what I have not talked is the localization layer or navigation stack. What is called, first you understand, now we understand what is called sensing stack. Sensing stack means I have my onboard payload or my onboard sensors which is moving with my system or with my vehicle, and I am taking a output and a kind of image of the external world. So, this is my sensing layer. Next come my localization or navigation layer. What is called navigation? Navigation or localization means I want to gather information of my own. I want to know what is my position, I want to know what is my velocity, I want to know what is my attitude or orientation, how am I oriented with respect to a global coordinate system. So, this is very important. Without this, we cannot generate any kind of sensing or cannot process any kind of sensing information, because radar gives me in range. What is range? Range means what is the distance from my vehicle and from the actual world. So, it is a relative distance from the target to your vehicle. So, you need to know what is your location. If you do not know your relative location, then you will not be able to model the range. So, that is what your navigation system all about. So, there are navigation system using your traditional navigation system, your strap down navigation system using IMU. So, or IMUs means your gyros, accelerometers, which will sense your body rates plus your accelerations plus your magnetometers and baro altimeter. So, these are all the your standard navigation system, plus you have the GPS devices. Now, every even cars and or even sometimes your high end bikes also have their own GPS receiver, which will give you own kind of positioning, and in the absence of GPS you have some camera or vision sensor to generate using some visual odometry technique to kind of thing to your position. So, localization and navigation will give you, or navigation stack will give you primarily your kinematic information, primarily your position, your velocity, your body rates, everything with respect to a global coordinate system. Okay. That is important to process your sensing or perception function. You processed it, once you processed it, they are raw data. Now, sensor giving you raw data. Raw data will be contaminated with noise, there will be clutters. Clutter means what? Clutter means I can see a false target. The target actually your sensor is saying this is there is a target here, but actually there is nothing. This is a false detection. Okay. So, how to now filter it out? So, that part is called the perception function. The perception stack actually does that. Stack does that. So, sensor is your hardware, sensor gives you information. Now, that you will process somewhere, that is we will process within the perception stack or perception software. Once you process that, so it will give you a, it is actually giving you some chain of information, detection, tracking, classification. Okay. So, this is actually what is the intention of this course. In this whole lecture series, out of it you will be knowing the perception stack. Obviously, but this is not completely autonomous system functions. You have to have localization stack, you have to know planning, and then you have to do control and actuation. Okay. So, they are another kind of course, they are different courses that will be kind of maybe later or somewhere else. So, the purpose of this course is the first one, sensing and perception stack. So, with this kind of a thing of the sensing and perception stack, I just come briefly, I will tell you briefly on the planning and control stack. So, planning means now suppose your information is processed, you know what is kind of your detection function or your detection images, you know what is you are able to track. What is track? Track means actually you want to follow the trajectory, you are following the trajectory of the moving vehicle, or even you want to continuously monitoring it. And classification, you all know, classification means what kind of object it is, whether it is a static object or whether it is a moving object. Even for an, let us take an example in a car, you are driving a car, many people knows driving. So, you are driving a car, you have some sensors, say some camera. So, with the camera you want to kind of capture the image of a pedestrian. So, pedestrian is moving. So, when you are tracking the pedestrian is moving, so that part is called your tracking function. Now, you identify that okay, this gentleman, this is a pedestrian, then that is called a classification. So, once you do, and sensor fusion is that you want to track the pedestrian using a say an FMCW radar plus a camera, with both you are kind of tracking the pedestrian. Okay. Now, you want to fuse the both data together. So, that part is actually called fusion in an optimal way to get the better information of the pedestrian. Clear? So, with this it is your perception function, a DTC function, what we will be talking is clear. Next is planning. Planning, I already told that you want to now, you now know there is a pedestrian in front of you, you want to kind of change the path, so that you are not in a collision course with the pedestrian. That part is planning. And next is the control actuation action. So, how will you achieve your desired path? By means of an or some actuator within your car. Okay. With this, I am going to some case studies that will be interesting. With the case studies, actually what we will be teaching today, first is an example of called autonomous driving. Autonomous driving is very famous these days. Almost all car, even if anyone is aware that or in the MORTH or Ministry of Highways and this authority of government of India, it is kind of designated that from 2026 onwards, all the four wheelers will have to have some kind of level 2 or level 3 or some kind level 2 plus some kind of ADAS, be it Maruti Suzuki vehicle you have or Mahindra vehicle you have or any other car manufacturer vehicle you have, any high end car manufacturer vehicle you have. Everything will have to have some kind of some ADAS just to prevent the accident or give some alert to the driver, so that risk of accidents are minimized. So, in this example what we will know that what are the kind of sensing systems that are there within suppose your vehicle. So, you have here I have already chalked it out. Okay. So, you have your radar, obviously a very important function, long range radar. What is the range of this radar? Maximum 250 to 300 meter, not more than that. If it is a short range radar, it will be 120 to 150 meter, mostly 120 meter, not even beyond 120 meter you won't get detections with good RCS or good signal to noise ratio, strength and all. Okay. Radars are very useful. Why radars are useful? Radars are kind of all weather sensor. In each and every weather, this electromagnetic, this pulses you will be getting. Okay, there are other problems, but radar is used in that way sense. Then you have LIDAR. LIDAR is costly. Radar is cheap again. Another good advantage is radar is cheap, but LIDAR system is bit costlier. Okay. So, and it operates with the light. When we are pushing the light and you are getting the return, so that is the LIDAR. You have the camera system. So, camera system what it will do? Camera system actually it is a monocular or monochromatic or any kind of pan tilt kind of a camera. It gives again the information. It is with a very good resolution, with a very good resolution is better, plus the FOV. FOV is also good, but camera is not all weather. Your daytime another thing, night time another thing. So, and if you want to improve your image quality, you have to spend your hardware and money to your hardware and finally these things. Okay. Radar I have already talked, short and medium range radar. So, with all this thing you have your sensors. Now, sensors how it is mounted? You know how you are driving the car. Okay. So, this is called your front bumper. In the front bumper you place a FMCW radar, which will kind of give you kind of a say 250 to 300 meter of coverage. So, if you follow this line, this is say your radar field of view. So, with this radar field of view you want to perform some function. The functions are not very important at this point in time, just I am telling that how the sensing system is working. So, now every car is coming with these sensors. Now, if you have short range radar, you connect the short range radar to your mirror, your side screen mirror. Under that you have two short range radar. So, they are kind of covering the entire kind of cross views of your mirror. So, this is the part that so this area is covered by this short range radar, say 100 meter, 120 meter. Why it is there? Because if there is a blind spot, you are driving a car, if there is a blind spot, so that one vehicle should not kind of come as a crossing and hit you. Okay. So, these sensors I have placed here, plus you have a 360-degree cameras in all where. So, you have something here, you have something here, even here, even here. So, which will give you the full 360-degree protection. So, this is a very high end vehicle that I am talking. Normal vehicle will maximum have even at least 2 short range radars here and 2 short range radar there. But even if you have camera, you have 4 cameras along with the whole the vehicle. Here also there is a radar. So, you have seen the back side is also covered. So, for this kind of high end vehicle you have a 360-degree view to that person, the driver who is sitting, who is driving the car. So, he knows he has nothing to worry about his blind spot. Even he is parking the vehicle in a congested parking, in a very small narrow parking and all, he has the information where he will get a hit or he will get this kind of this thing. So, your sensors is assisting himself to drive. So, this is actually an autonomous system. Now, sensors are giving you information, radar is giving you what in terms of range, azimuth, Doppler in a 2-dimensional. Elevation is normally not so great, but you get all these informations okay, from radar. Camera is giving you in terms of pixel and coordinate x and y or the x and y position. LIDAR is also giving you position plus the some amount of velocity as well, LIDAR is also giving you. So, with all these 3 informations are coming, it will be processing somewhere, that will be processing inside a ECU or some kind of controller. We call it in autonomous driving term, it is called domain controller. So, this in the controller, it is just a card, it is a card. So, sometimes your this semiconductor companies like NVIDIA or Qualcomm, they also having this kind of a domain controller card, where all the information from the sensor will be processed. That processing, sensor processing, is your actually function, is your called perception function. So, there we will be now dealing with detection processing, tracking and sensor fusion and classification. So, all these functions will be kind of embedded, or kind of the functions will be there in within this system on chip. Okay. And based on that, your behavioral planning, path planning, and then what are the actuation, these commands will be transmitted. Okay, clear? So, this is a actually simple thing. So, now if I go to the details of this in a kind of block diagram structure. So, you have seen, now first let me talk about the sensors. So, I have seen that already told you these things: FMCW radar, adverse weather, long range and low light. You have your camera, angular FOV, obstacle classification, and obviously traffic light and traffic sign determination, which is not, you can understand, it is not possible from a radar point of view. LIDAR, your depth and 3D long range, already we talked. There are something called extended horizon sensors. What are they? They are 5G V2X. This again will be kind of in European road, this is very much there, but for Indian road also this is kind of coming in soon. You have 3D HD maps from Google Map, high resolution maps, and you have some kind of positioning system which will give you instantaneous position of your car using IMU, GPS and camera. Okay. So, this is the total kind of a flow diagram of the autonomous driving. What is called RDI? RDI means radar detection image. So, raw radar detection data. The radar is a hardware, radar hardware is giving you some data in terms of some measurements, or some if it is a SAR radar, it will give you some kind of image in terms of RDI, radar detection image. CDI is called camera detection image. LDI you can obviously understand, it is called LIDAR detection image. So, with all this detection image, you have this processing modules. So, this is called your tracking and classification module. Well, deep learning and all we will be talking later. So, then camera module, camera processing module, LIDAR processing module. Processed informations are coming here, 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 and they are feeding into, you need to fuse them intelligently. How you fuse them? We will talk about some methods and all in the later part in our lecture, and so we will fusing them. Once you fusing them, and you also fuse with the V2X sensors. So, this kind of 5G sensors which will also give you in the surrounding road. So, actually V2X sensor is kind of a sensor which is mounted on your on each and every of your vehicle. So, they are also giving some kind of road information in terms of road objects. So, if you have any obstacle in front when you are driving or not, or this, or there is some road blockage is there or not, or there is a pothole is in the road or not. So, they will give you this information. So, all this information you are processing in this computer or in the perception stack system on chip. Okay. Once you do this, you get the perception object list. Once you get the object list, then you come to the planning or behavioral stack. So, that means you now want to do what is the behavior, what I am supposed to do, what is my best thing. Okay. So, that is kind of a planning stack. Once the planning is completed, then you take action, that is your control stack or actuation stack, whatever do. For a car, you have lateral longitudinal control and all. So, from planning till the control command generation, this entire part except the sensors, forget the sensor, this part is within a card, okay. So, or within a kind of a system on chip. Okay. So, that performs all this computation. We will be in this course, we will be only talking about perception functions. Planning and control is not part of the course, but this is the main thing. So, perception function is what we will be teaching. Okay. So, thank you for the first lecture, and this is actually I have given an example of autonomous driving, a commercial civilian application. In the next lecture, I will be dealing the same thing in a more in a military context or an UDA context, I will say, Observe Orient Decision Act. Okay. So, thank you very much for the first lecture.